everyone, this is Neha and here I am with another video on elements, compounds and mixtures. In this video, we are going to discuss important topics and definitions related to it. With this, we will also review those topics from your book, and at last, you will also get answers of check your problems. So without further ado, let's get started. Things around us like air, water and gold are made up of matter, yet they are different from each other. Matter exists in different forms. To make the study of matter easier, scientists have classified it into three groups: elements, compounds and mixture. Beginning with elements. Now, elements are the substances that cannot be split into simpler substances by ordinary chemical changes or physical changes. The next point is each element has its characteristic properties and is different from other elements, and they exist independently. A large number of elements, about 180 known elements, are present, but out of them 92 occur naturally. Moving on to the symbols which we use to denote an element. A symbol is an abbreviation for the name of an element. It represents an atom of an element. Now, naming an element cannot be done in any way. We have to follow certain rules which are approved by IUPAC, that is International Union of Pure and Applied Chemistry. And according to it, there are three different ways in which we can name an element. First is, the symbol of an element corresponds to the first one or two letters of the English name of that element. Okay. For example, the symbol of hydrogen is H and that of aluminium is Al. Moving on to the next rule, that is, if more than one element has the same first letter, their symbol consists of two letters. The first letter followed by another letter that is not common. For example, the symbol for chlorine is Cl. We have another element which has the same first letter, that is carbon, C. So we cannot denote chlorine and carbon with the same first letter. So in this case, what we took for chlorine, we took the first two letters which are not common. Okay. Next is, symbols of an element are derived from the Latin name. So suppose the first letter and the second letter of more than two elements are same. In that case, what we have to do? We have to take their Latin name. And there are certain elements whose Latin names are taken in order to represent their symbols. Let's review your book. Now, what are elements? An element is a substance that cannot be broken down into simpler substances by any physical or ordinary chemical means. So this is the definition of an element. There are 118 known elements today, and out of which 92 elements occur naturally, and the remaining elements are made by humans. Okay, what is the characteristical property of an element? That it exists independently. It exists independently. Or it can combine with other elements to make the millions of types of a substance. Okay, so this was about the elements. Moving on to the symbols of an element. So what is a symbol? Elements are represented by symbols which are two or one letter abbreviation. Okay, that is the definition of a symbol, which should be approved by IUPAC, that is International Union of Pure and Applied Chemistry. The first rule was the symbol of most elements correspond to the first one or two letters of their English name. Like aluminium. Aluminium is Al. The first letter of aluminium is Al, therefore aluminium is denoted by this Al. The next example is hydrogen. Here hydrogen starts with H, so it is denoted by H. The symbol of hydrogen is H. Now the next rule is, if more than one element has the same first letter, their symbols consist of two letters. Okay, as I have given you the example of chlorine and carbon. Chlorine first letter is C and that of carbon is also C. So what we will do, we will take first two letters. So for chlorine we have taken first two letters, that is C, L. Okay, this was about the review of your book. Now the rule number 3 is, the symbols of an elements are derived from the Latin name. So if there are more than two elements which have same name, same first letter, for them what we have done, we have taken their Latin names. Okay, Latin names. So here are the examples. Suppose potassium, potassium's Latin name is kalium, so therefore we denote it as K. Sodium, Latin name is natrium, and the symbol for sodium we have taken as Na. So these symbols follow the Latin names rather than following their English names. Okay, and here you can see this table, the elements, these are the elements, and here you have the symbols which follow the English name of the elements. Okay, so this was about your symbols of element. Moving on to molecules. Molecules. Now atoms usually do not exist independently. They generally combine among themselves to form molecules. And what are molecules? A molecule is the smallest part of an element or a compound that can exist independently. So when an atom of an element combines with another atom of the same element, a molecule of the element is formed. Okay, for example, two atoms of hydrogen. Okay, two atoms of hydrogen, they combine to form a molecule of hydrogen. Okay, okay, similarly two atoms of nitrogen, they combine to give one molecule of nitrogen. Okay, so this is how a molecule forms. Moving on to atomicity. Now what does atomicity means? The number of atoms present in a molecule is defined as atomicity. Now atomicity are of three types: monoatomic, diatomic, triatomic or polyatomic. Now what are monoatomic? If they contain single atom, they are known as monoatomic. Diatomic, if they contain two atoms, that is diatomic. Triatomic are if they contain three atoms, then they are known as triatomic. And polyatomic, if the molecule contains more than two atoms, then they are known as polyatomic. Clear? Let's go through your book. Let's review your book. Okay, atomicity here. The definition of atomicity you have to learn. It means the number of atoms present in a molecule of an element is called atomicity. Okay. What are monoatomic? If they contain single atoms, then they are known as monoatomic. Okay, mono means single. See here. Then diatomic. Diatomic means if they are made up of two atoms, then they are diatomic. Okay, di here means two. Tri, if they are made up of three atoms, they are known as triatomic. For example, ozone. And polyatomic, if they are made up of more than two atoms, they are known as polyatomic. Okay, for example, phosphorus. So this was about your molecules of an element and atomicity. Moving on to compounds. Let's move on to compounds. Now what are compounds? Compounds are the substances that can be split into two or more simpler substances by chemical means. But in case of elements, it cannot be split into simpler substances by any of the chemical or physical means. Okay, so this was about the compounds. Let's go through the characteristics of compounds. So a compound are generally made up of two or more elements which are combined in a definite proportion that forms an element. Okay, always made up of same elements. The compounds are always made up of same elements, and they are always homogeneous. Their composition is uniform throughout. The properties of compounds are different from those of its elements. Okay. For example, water can split into two simpler substances, that is hydrogen and oxygen, which are the elements. So the properties of water is completely different from that of hydrogen and oxygen. Okay, so the properties of the compounds are different from those of its elements. Number 5 is, it is impossible to separate the constituents of a compound. You cannot separate the constituents of a compound by any of the physical means. You can separate the constituents of a compound by chemical means, but you cannot separate it by any of the physical means. Suppose again water. Okay, water can be separated into hydrogen and oxygen only by a chemical means, that is electrolysis. You cannot do it by physical means like boiling or filtration. Okay, you will not be able to separate the constituents of compound, that is water. It cannot be separated into hydrogen and oxygen by simple physical means, that is boiling or filtration. Moving on to the last one, that is energy is either given off or absorbed during the formation of compound. So whenever a compound is formed, energy is either absorbed or it is released. Okay, so this was about compounds. Let's go through your book. So this is the definition of compounds. A compound is a substance made up of two or more elements, and the elements in a compound are chemically combined in a fixed ratio. Okay. Characteristics of a compound. A compound is made up of two or more elements. This was the first characteristics of compound. A compound is always made up of same elements combined in a fixed ratio. They are not formed by any ratio. They have a fixed composition in which they combine. Okay, water is made up of 2 hydrogen and 1 oxygen. So that is a fixed ratio in which the water is formed. Okay, and moving on to the third characteristic. A compound is always homogeneous. It doesn't change from place to place. Suppose say water which is present in your place will have same composition to the water which is present in all the water bodies, okay, rivers, oceans and all. The composition is same throughout the universe. So a compound is always homogeneous. Okay, the properties of compound are different from those of its constituent elements. I have told you, I have explained you by giving the example of water. Here you have one more example, that is of sodium and chlorine. Now, sodium and chlorine are poisonous substances. Okay, individually sodium and chlorine are poisonous, but when they combine and form sodium chloride, that is the name of the compound that is formed when sodium and chlorine are combined, that particular compound can be added to our food, which means it is non-poisonous. So earlier sodium and chlorine individually they were very poisonous. So the characteristics of the elements individually is completely different from the compound. The compound formed is sodium chloride. Okay. Next, it is not possible to separate the constituents of compounds by physical means. You cannot separate the constituent of a compound by physical means. That is, I have given you the example of water. Okay, physical means by which we can water can be separated are boiling and filtration. So tell me, by boiling or filtration, okay, if you boil water, do you get hydrogen and oxygen separately? No, you get water in some other state, that is vapor. Okay, so therefore water, which is a compound, cannot be separated by any of the physical means, that is boiling, filtration or any other method. It can only be separated by a particular chemical process. Okay, that is electrolysis. Electrolysis is for separating water. There are other methods by which the other compounds can be separated. So it depends on the compound. The last is, energy is usually given off or absorbed when a compound is formed. So whenever a compound is formed, either energy is absorbed or it is released. Now here is the example of again water. When water is formed, what happens? Energy is produced in the form of heat and light, which we use as electricity. Okay, so this was about compound and the characteristics of compound. Moving on to the molecules of compound. In the previous section, we talked about molecules of element. Here we will discuss about molecules of compound. When the atoms of two or more elements combine, they form a molecule of a compound. Okay, we have some of the examples of molecules of compound here in your book. Let's go through it. A water molecule. Okay, water is a compound. So water molecule is formed by the combination of two atoms of hydrogen and one atom of oxygen. As I have told you, compounds are always formed in a fixed ratio, and this is the fixed ratio of water. Another example is that of molecule of carbon dioxide. Now carbon dioxide is a compound which is formed by the combination of two different elements, and the elements are one atom of carbon and two atom of oxygen. Okay, so this was about the molecules of a compound. Here you can see there is difference between elements and compounds. Parameters are constituent, separation, properties and molecules. These are the parameters, which means these are the things on which the elements and compounds are separated. Depending on the constituent, elements are made up of only one kind of substance. Okay, but a compound is made up of two or more elements. Clear? Separation. An element can be broken down into simpler substances by chemical means, but a compound, elements cannot be broken. Okay, elements cannot be broken down into simpler substances by chemical means, but a compound can be broken down into simpler substances by chemical means. How we have seen the example of water, because water can be broken down into simpler substances by the chemical change, that was electrolysis. Okay. Properties. An element has its own set of properties. Okay, but a compound, the properties of compound are completely different from that of its constituent elements, like sodium and chlorine. Okay, sodium and chlorine individually, the elements are completely different in properties than the compound that is formed, which is sodium chloride. Okay, sodium chloride is non-poisonous, but sodium and chloride are poisonous substances. Moving on to the molecules. The molecules of an element are formed by the combination of two or more atoms of same element. It should be same element and it is formed by the combination of two or more atoms. But here in case of compounds, what happens? Two or more elements, they combine and they form a molecule of what? A compound. Okay, so this was the difference between elements and compounds. Hope you have understood this. Here, as I have told you, check your progress, you have your answers here, please go through it. Next we have is mixtures. A mixture consists of two or more substances in any proportion. They do not have a fixed proportion like that of compounds. Okay, such that they do not undergo a chemical change. The constituent which are present in the mixtures, they do not go any chemical change, we have to keep in mind. Okay, so this is about mixtures, or you can say a mixture is a substance containing more than one element or compound in any proportion. So it can have elements and compound, both it can have, or it can only have elements, different types of elements, or it can have different types of compounds. Okay, so mixture doesn't have any fixed proportion, and as well as it can have both elements and compounds in it. The components of the mixtures can be separated by physical means like filtration, sublimation, distillation. All these are physical means by which a mixture can be separated. But in case of compounds, what we did, we can only separate the constituents of compound by chemical means. Okay, you can understand the contrast between mixtures and compounds. Okay, so mixtures basically there are of four types. Okay, First is homogeneous mixture. Now homogeneous itself says that it is uniform. Okay, so homogeneous mixtures are the mixtures which have uniform constituents. The constituents which are present, they are uniform. Heterogeneous mixtures are the mixtures which are non-uniform. The constituent present in the mixture are non-uniform. Suspension. Here suspension is a heterogeneous mixture, which means the constituents are non-uniform, as well as the solid particles which are present in the suspension, they are in suspended form. They do not settle at the bottom of the container. They are in suspension form. Okay, suspension means they are floating in between the whole mixture. Okay, suppose this is a beaker and it is filled with water. Okay, filled with water. Clear? And these are the small particles of mixture, okay, which are floating or which are in the suspended form. So this is suspension. Clear? What is suspension? It is a heterogeneous mixture. See, suppose if I take this particular area, it is heterogeneous. Okay, this one is heterogeneous. Okay, here suppose 3 particles are present, but here are 1, 2, 3, 4, 5, 6 particles are present. Okay, so this is heterogeneous. Clear? What is suspension? So suspension is a mixture which is heterogeneous in nature, and the solid particles whichever are present, they are in suspended form. See, these all are in suspended form. Moving on to emulsion. What is emulsion? It is also a heterogeneous mixture. Okay, and in emulsion what happens, one liquid does not get dissolved in the other liquid. We have taken 2 different liquids. Suppose if we have taken in this beaker, okay, you have filled it with water. Okay, so this is completely filled with water. And in this water you have added kerosene. Okay, so what happened? It will form a emulsion. How? Because this water is not going to mix with this kerosene, so it is an emulsion. So this is heterogeneous mixture. Okay, this kerosene is not uniformly distributed in the water. Okay, so this is an emulsion. Okay, understood what is an suspension and emulsion, difference between suspension and emulsion. Okay, moving on to review your book. Now what is a mixture? A mixture consists of molecules of 2 or more substances. Okay, so these substances can be elements, or it can be a compound, or it can be both element and compound. Okay, here elements, compounds, or both in any proportion. They do not mix in any fixed proportion. They can be mixed in any proportion. But what is the condition? They do not go any chemical change. There should be no chemical change between the constituents present in a mixture. Okay, thorough with this. Moving on to the type of mixtures. So here it is. First 2 types are homogeneous and heterogeneous. Homogeneous mixture was the 2 or more. Homogeneous mixture was they have uniform constituent and properties throughout. The properties and the constituents which are present in the homogeneous mixture is uniform throughout the mixture. But in heterogeneous what happens? They are non-uniform. Okay, here you have a term alloy. What is an alloy? It is a solid mixture of 2 or more metals, or it can be a metal and non-metal. Okay, it is a homogeneous mixture. This is an alloy. And brass, bronze, these are all alloys. Moving on to heterogeneous mixture. Now heterogeneous mixture, as I have told you, they do not have a uniform constituents and properties throughout the mixture. Here you have got the example of sand and common salt, or you can also have an example of sand and iron fillings, or iron fillings and sulfur. kerosene and water. Okay, these are all heterogeneous mixtures. Moving on to suspension. Suspension, I have told you, these are heterogeneous mixture in which the small solid particles are suspended in a liquid. Okay, solid particles are suspended in liquid. Okay, and what is emulsion? Emulsion is also a heterogeneous mixture in which the constituent particles, that is one liquid dispersed, which is not dissolved in other liquid. For example, milk is an emulsion. Okay, so this was about your mixture and different types of mixtures. Moving on to the characteristics of mixture. The first one is constituents may be present in any proportion. Okay, they do not have fixed proportion like that of compound. Now let me give you an example. Suppose air. Okay, air is a mixture that contains elements as well as compounds. So what are the elements which are present in air? Okay, that are, so elements are oxygen, O2 and nitrogen. Okay, N2. So these are the elements which are present in air. Okay, these are the elements which are present in air. What are the compounds which are present in air? Carbon dioxide, CO2, okay, and water vapor, H2O. These are the compounds. So I have told you that mixtures are made up of elements as well as compounds. Okay, so these are the elements and the compounds. Unlike compounds, the composition of mixtures may vary. Compounds have a fixed composition and the properties are also somewhat fixed, but in case of mixtures, they does not have any specific property. Okay, mixtures don't have a specific property. They do not have fixed melting point or boiling point. The melting or boiling point of a mixture is not fixed, and they can be separated by physical means. Physical means, as I have told you, filtration, sublimation, distillation. These are the physical means by which the components of a mixture can be separated. Now let's go through your book. The first characteristic is the constituent of a mixture may be present in any ratio or proportion. Okay, so this one I have told you, they can be present in any proportion or any ratio, that is not fixed. Next is, a mixture does not have any specific property of its own. They don't have a specific property of its own. In a mixture, each constituent exhibits its original property. Okay. For example, pure oxygen supports burning and does not have, and the oxygen which is present in the air, it also supports burning. But in compound, what happened? Compound, earlier the constituent which were there, when they formed compound, their properties changed completely in case of compounds. But in mixture, what happens? They are not present in any fixed proportion. So what happens? Whenever if you see here, it has been taken the example of oxygen. Okay, oxygen in pure state, it has the property of burning, and when it is present in mixture state, which is in air, it supports burning. So its property doesn't change. Whenever a constituent forms a mixture, its properties remain unchanged. So this is what the second point is telling you. The mixture does not have a fixed melting or boiling point. Okay, they don't have a fixed melting or boiling point. See, a mixture of 1 spoon of table salt and glass of water. You have made a mixture, okay, and start boiling it. It will boil at a particular temperature, and if you take same glass of water, plain glass of water, and you add 2 teaspoons of salt to it, it will boil at a particular temperature. So there will be a difference between the boiling point of both the mixtures. Therefore, they do not have a fixed melting. That it depends upon the constituent in which are added in that mixture. Okay. Now, fourth point is the constituent of mixtures can be separated by physical means. They can be separated, as I have told you. You can use filtration, you can use distillation, you can use sublimation, and all other physical methods which are used. Here, salt can be separated from iron dust by using magnet. So let's take an example of salt in water. you have added salt to a glass of water. That is a mixture. Now how can you separate that water from the salt? If you're boiling is a physical means by which you can separate. Okay, when you boil water, what happens? The vapor comes out, and what is left behind? Water. So in that way you have separated the mixture of water and salt by a physical means, that was boiling. Okay, so this was about the different properties what mixtures have. Moving on to the need of separation, like we have separated water from salt. So what is the need? Why we need to separate mixtures? Now the first reason is to remove harmful or undesirable components. Okay. Suppose water that we are drinking, it consists of, before filtration, okay, it consists of many bacteria, it consists of many algae, clay substances, different kinds of oils, sand, silt, gravels, all these things are present in water. So we cannot drink that water because it is not fit for us. So what we need to do? We need to filter it out. Okay. Now when water was with all those constituents of bacteria, fungi, algae, and those sand particles, oil particles, or whatever, it was in the form of mixture. We filtered it out. Now filtration was the separation of the mixture by using physical means. Okay, getting the point? So what was the reason behind doing all those process? So that we can remove the harmful or undesirable components which was present in the water, so that it becomes fit for all of us, so that we can drink it. Okay, so the first point is clear, why we need to separate the mixtures, so that all the harmful or undesirable components whichever are present in it, they can be removed. Second is to obtain the useful substance. So while we have separated the water from its constituent, the harmful constituent, what we got? Water, which is the useful substance. Clear? So we need to obtain in order to obtain the useful substances, we need to separate mixtures. Here the next is to obtain the pure sample of the substance. Sometimes what happens, we need to get the pure substance. Okay, suppose say the example of air. Air contains oxygen, hydrogen, nitrogen, carbon dioxide, all those things. Okay, we need oxygen. So what we need to do, we have to extract that oxygen from air. Okay, so that we get a pure sample of oxygen. Why? So that we can use that oxygen in various medical purposes, or for different reactions in the laboratory, or different types of scientific methods. So we need that pure substance. So in order to obtain the pure substance, we have to separate the mixture. Clear? All these 3 points. Let's go through your book. First one is, as I have told you, to remove a harmful or undesirable component. The component in the water are sand, oil, clay, microorganisms like bacteria, fungi, algae, all these things are microorganisms. Okay, so we have to remove these so that we get the pure water. Second is to obtain a useful substance. Here it has the example given to you is petroleum oil. Okay, now petroleum oil consists of a mixture of petrol, diesel and kerosene and many other substances also. So we have to separate the mixture which is present in the petroleum oil so that we can get the fuel from it. Okay, to obtain the pure sample of substance, many substances are required in their pure form for scientific research and making medicines. Okay, so whatever substances we need for the scientific research and medicines, in order to extract that one, we have to separate that particular constituent from its mixture. Clear? So this was all about the whole chapter. Stay tuned until we meet next time. Thank you for watching.